Either this is Forces Lesson 19, and this is terminal velocity. And the objectives are to be able to explain what terminal velocity is and appreciate that a parachutist will have two terminal velocities, and you should be able to recognize or draw a graph of a falling parachutist or person. So there's no maths in this one, apart from some numbers, but there's no calculations or anything. There's just a word for it at the end, but it's, you might want to make some notes to help you try and remember the content. So falling objects. Quite a classic GIF, that. Classic video, you can find it on YouTube. So when an object falls through air or some other fluid, initially the only significant force acting on it is the downward pull or force of gravity. So on Earth, you should already know that the acceleration due to gravity is 9.8 meters per second squared. Remember to pause and make any notes if you wish. So as the object speeds up, in that GIF it was a basketball, it could be anything. Frictional forces, by frictional force I mean like air resistance, becomes greater. And it becomes greater the faster the object moves. Eventually then, the resultant force on the object will become zero. So if you've got the weight acting down, maybe it's 700 newtons, and eventually the air resistance will start at zero and build up and build up and build up, and the faster you go until eventually it will also be 700 newtons. So eventually the resultant force on the object will be zero when the frictional forces or the drag equal the weight of the object. And what we call that, the object then moves at constant speed, and we call that terminal velocity. So as you can see on the right, we've got an object in a liquid. So as you can see from the size of the arrows, we've got the weight of the object and the drag force, and they're equal and opposite. So what's happened is this ball, although it's not fallen very far, has significant drag, and it's significant enough to be equal to the weight of the object. Therefore, the object or the ball in that liquid will fall at a constant velocity, which we call the terminal velocity. In air, it takes a lot longer. When you're falling in air, it takes quite a while to get to your terminal velocity, where the weight is equal to the drag force. So here's an example of a velocity time graph for a falling object. As you can see, the object in liquid reaches this specific liquid reaches its terminal velocity at 1 meter per second, and as you can see, an object in air will just keep going in a linear fashion in this region. So what about parachuting? So a parachutist will have two different terminal velocities. Before opening the parachute, the terminal velocity of a person falling is approximately around 60 meters per second, or 140 miles per hour. Afterwards, however, due to the much greater drag force, the terminal velocity is about 5 meters per second, or 12 miles per hour. Obviously, if you're going to land on the floor, you would much rather do it at 12 miles per hour compared to 140 miles per hour. So when the parachute is opened, a common misconception is that the parachutist will fly back up into the air. That's not the case. What happens is that the parachutist will decelerate down to this lower velocity. I believe that misconception comes from, so people film each other while they're falling, and one person will open the parachute. They will start to decelerate, slow down, whereas the person with the camera keeps falling at over 100 miles per hour. So it gives it's a misconception that you would go back up. You don't, you just slow down or decelerate. All right, let's move on. So velocity time graph of a parachutist. So we've got velocity against time. So first bit's linear. And then the rate of increase of speed the rate of acceleration starts to decrease until it levels out in the straight region at the top. So initial acceleration is approximately 10 meters per second squared. Remember, on Earth, the surface of the Earth, it would be 9.8 meters per second squared due to gravity. So you reach a first terminal velocity, which we said, around 60 meters per second or 140 miles per hour. Open the parachute, decelerate quite rapidly, down to a second terminal velocity, and then reach the ground. So if you ever see a graph like this, it's either a parachutist or, well, no, it is a parachutist, yeah, because there's a second terminal velocity. So if you see that, it is a parachutist. Right, let's finish with this word fill then. So you can write this down if you wish. You can have a go now if you want. You can pause it without any of the keywords. If you want a little bit of help, I will put the keywords on next. And then I'll take you through the answers. So this is a good consolidation. Weight is the force of gravity on an object. Weight is equal to the mass of an object in kilograms multiplied by the acceleration due to gravity. Near the Earth's surface, a mass of 1 kilogram weighs approximately 10 newtons. When an object falls through a fluid, it initially accelerates because of gravity. As its speed increases, so do the frictional forces. Eventually, the frictional forces are equal to the weight of the object. At this stage, the resultant force on the object is 0, and the object falls with its terminal velocity. Now, in an exam, you can be asked, about a mass that's falling, and be asked to talk about it in terms of forces, and this is actually an excellent answer for certain types of questions. So if you're going to write any of this down, I would advise writing this down and learning it. Alright, thanks for watching. I hope that's helped, and I'll speak to you soon.